Cool. So welcome everyone to the SQL topical review session. I hope you're having a great dead week and a great Tuesday. I think it's Tuesday at least. Reminder, our final for this class is next week. There are other topical review sessions. I hope you can either watch the recordings or go to those. If you can, for the people that are here, if you could turn your camera on, that would be great, just so I can see some people when I'm talking. But yeah, as always, if you have any questions, feel free to put them in the chat, and Alina, our great tutor, will be here to help out. So let's jump right into SQL, if I can figure out a way to share my slides. Where did it go? Okay. So just to check, can you guys see my the slides right now? Cool, perfect. So, okay. Also, if you could mute yourself, if you want to like ask a question, feel free to unmute yourself. But until then, if everyone could mute yourself, that would be great. So agenda for today, we're going to talk a little bit about the SQL syntax, talk about some problem solving strategies. Again, the conceptual idea of SQL, I would say, isn't too bad, but there are some, it's like solving it that can get kind of iffy. And then we'll do a lot of practice problems. Like I said, I'll probably put you guys in breakout rooms for that. Yeah, let's just jump right in. So what is SQL? Like, why are we even like talking about SQL really? And it's pretty neat, right? It is very different from essentially everything we've done in the class, if I'm going to be honest. So it's a declarative programming language, which is different from before. It's basically, okay, I'm just going to mute everyone quickly. So basically, the program describes what the result should look like and doesn't know really how SQL is giving that answer. And that's different, right? In Python, in Scheme, we basically told the computer, these are the steps I want you to take, right? Create this list, do something in this for loop. This is the while loop. We're not doing that in SQL. It's a lot easier. We're saying, this is the table I want in the end, or this is the table I want to create. And once we tell it how to do that, it basically figures out like the steps in getting there. So that's different from an imperative programming language like Python and Scheme. So the first step of that is like creating these tables. When you create a table, you just use the create table command. You give the table a name, then you say as. That's basically saying, okay, what am I going to create the table as? And then you can give it these rows. So you say select, you put your value. So let's say I'm doing like the favorite things of students, right? So I'm going to say like select blue or maybe Richard as name. So this first column is going to be the name of the student. Blue as color. My favorite color is blue. And I can keep doing these value as columns. And that's basically saying in that column, this is the value I want to give it. So in that row, those are the values. Once you're done with one row, you say union. That means there's another row coming afterwards. And you keep going on and on. You give it the values. The neat thing is, once you give it the columns in the first row, as long as you match up the right numbers in the second row, you don't need to give it the columns anymore, right? If it's name, I don't know, name, color, name, color, and then food, as long as I keep going with name, color, food in that order, it's going to place it in the right column, right? As long as I put it in the right order, everything will be okay. And then in the end, as always, once you have no more rows to add, you put your semicolon. All SQL statements end in a semicolon. And that creates your table and with all your rows. Typically, this isn't the type of problem we see. You were usually given the table already created, but you might see something like this. This is kind of the big thing, right? Select statements. Even if you're like very, very unfamiliar with SQL, select is kind of like the big thing you're supposed to know, right? Like a couple days ago, my mom was like, oh, I don't remember much from SQL, but like I remember select. And that was like 20 some years ago. So select is the biggest thing to know. And basically, it lets us choose things. It lets us create these tables out of tables, right? It's how we kind of choose data, choose rows, choose certain columns out of that kind of bigger table. So the first thing we want to always start off with is a select. And this is going to be the typical order you see throughout the most of these statements. You want to select, then you want to select some columns. So it could either be 2 columns, 1 column, multiple columns. You just say which columns you want. If you want to select all the columns, you can just put a star there, a little asterisk. From, And then you tell it what table or tables you want it from. If you put multiple tables here, that's joining. We're going to talk about that later. Where's where you give it some conditions, right? So maybe out of that table with the students' favorite things, I wanted to only figure out what students had the favorite color blue, right? So I could say something like where the color equals blue. And then it's going to look at the color column and only keep the rows that have the value blue in that column. So that's what where does. Where goes row by row and filters out certain rows based on some kind of expression or condition. That means we can have and statements, we can have or statements here. As long as it matches that condition, it will keep the row. Then we have order by. That kind of just orders by some expression. That could be, I want to order by a certain column. That can order by a more complicated expression with, subtracting some columns, the difference between columns, the sum of some columns. All of those are okay. And then you can say, is that going to be ascending or descending? The default is ascending, but you can say if you want descending as well. And then limit, you say, how many rows do I want in my output? I can put a limit there. So that's kind of like the bare bones, like this is the structure you usually want to follow. But again, that isn't the most helpful thing, right? Even if you had that, it doesn't tell you a lot about how you want to solve these problems, right? It doesn't tell you, which columns do I want? What, conditions do I want to filter by? Do I want an ascending or descending? Am I ordering? Am I not ordering? How do I limit? So we need to understand how to use this statement to solve these problems. So this is good to know, but it's not enough. So let's look at this example. So if I look here, we say I want to select the name, comma, price from fruits, where color equals orange, order by price, descending. So it says that this is the answer. Papaya 10, orange 2. Well, let's see why that's a thing, right? Let's see if we really understand what's happening here. So we see that, okay, we select the name and the price. So we can kind of get rid of the color row, but in the end, we're going to select name and price from fruits. So we're not joining anything. We're just taking it from one table. Where the color is equal to orange. So now we're doing a row by row filter on these on this table. So if we look through it, okay, that color is red, we get rid of it. Not orange, get rid of it. We keep these two and we get rid of durian. So right now our table only has orange and papaya, and we only have the name and the price columns. Then we order by price, and then we say it's descending. So we start with the bigger ones and go down, which means papaya and 10 should be at the top, and orange and 2 should be at the bottom, and that's exactly what we see. So again, this is probably the most simple example of like what a select statement can do. It's taking some data out of that table, given some conditions, given some filtering, and ordering it somehow, right? We didn't actually change anything here. We just took some data out of that table. Cool. So does anyone have any questions so far? Again, you can either unmute yourself, put it in the chat, either one works. Everyone doing okay? Cool. So now let's get kind of into the tricky stuff. I know a lot of you guys said that you wanted to talk about joins. So let's see if this isn't kind of enough. Feel free to ask more questions when I pause. So sometimes, in this case, we were able to get away with, just using the fruits table once, right? All the data was in this fruits table. But what if I wanted to create like pairs where I wanted to match up the two fruits or fruits that had the same color. So I wanted like orange and papaya in one row and banana and durian in another row. Well, I wouldn't actually be able to do that with just the fruits table once, right? If I look at a row here, it only has banana and the color and price. It doesn't have that kind of second fruit in that row. So sometimes what we want to do is we want to join tables together. And that usually happens when you need data from more than one table. And the syntax for that isn't too different. Basically what it is I want to select columns from table 1, comma, table 2. That's all you really need to do. Sometimes you'll see aliasing. So it'd be like, oh, from table 1 as A, comma, table 2 as B. That's if you have repeat column names. And then you need to do that to make sure you get the right columns. Because if I like joined this table twice, right? And it was name, color, price, it wouldn't really, I wouldn't be able to say which name column I want. I wouldn't be able to say what color column I want. So that's why we want to alias sometimes. The second issue with joins, so the first one is sometimes the column names aren't going to be great. The second issue with joins is it can create a lot of what I like to call like bad data or bad rows that really don't make sense. The way a join works, and we're going to see this in the next slide, is it basically matches every row in one table with every row in the other table. And it does that for each row. So in the end, you get like the number of rows in table 1 times the number of rows in table 2 rows in your new table. But because it does that kind of like, what's the right word? Like it matches all the rows together, you can imagine that some of these rows probably aren't going to make a lot of sense. If I go back to this example and I did that match and I was looking for the matching color, well, it would have, apple and banana in one row, an apple and orange in one row, an apple and papaya in one row, an apple and durian in one row. Even though those don't match kind of the criteria I'm talking about, right? I wanted the color to match. So usually when we join, the second thing we have to be careful of is we usually want to filter out some of the rows that we don't want. So there's usually going to be some kind of where condition where you filter out those bad rows. And I'll go into an example of that in a bit. So here's kind of the visualization I'm talking about. Let's say we have one table with 2 rows in one column, one with 3 rows in one column. So if I start matching them up, that means I need an orange blue, an orange light blue, and an orange black. And as you can see, I match them up and I just put the columns together. So I just concatenate the columns together, but I match up all the rows. And then I do the same for red. I get red blue, red light blue, and red black. So that's kind of the resulting table. So the number of rows is going to be rows times rows, so 6, and then columns plus columns. So this is a 6 by 2. Okay. Any questions on like how we joined those two tables together before we like dive deeper into what's happening in the join? So far, we've just joined the tables together, put them together. We have our bigger table. Everyone doing okay so far? Yeah. So the number of columns is just going to be the number of columns in the first table plus the number of columns in the second table, right? If I do this matching, like orange and blue, I multiply the number of rows together because, if it's 2 here, I have to match this by 3, match this by 3, so that gives us 6. But for columns, you just add it together, right? Once I match these two, I can just put them together. So it's rows times rows and then columns plus columns, which gives us 6 and then 2, which is what we have here. So that's, the join table. But like I said, we have to be careful with some of these, like, let's say the bad rows. And here they kind of say, okay, you can use where to filter it out. We need some kind of where condition. And then in pseudocode, this would be select star from table 1 comma table 2. That alone, if I just put a semicolon here, would create this table. How do I filter it out? I could say where the left color equals orange and the right color equals black. So what's that going to do? Left color equals orange would get rid of those 3. And then right color equals black would get rid of, does not equal black. Sorry about that. The double kind of like HTML tags or whatever they're called does not equal. Yeah, so you can either do like the regular exclamation point equal or the triangle brackets or braces, whatever they're called. So this is one case of, once we join the tables together, we can still do some kind of filtering. And again, that's just useful for, once we join the tables, we usually want to do something. Yeah, they both do the same thing. They're interchangeable. So it doesn't really matter if you use the triangle things or the does not equal. They're both fine. Great. And then that's kind of the resulting table we would get. So typically, if you join a table, you would never end up with like the entire massive join table. You always want to do some kind of filtering out of it. Cool. And just so you guys know, if you haven't, I mean, if you've come to either me or Catherine's discussion or lab, I'm sure you've seen this. But if not, the SQL web interpreter is super, super useful for just practicing SQL out. I highly recommend it. It's pretty easy to just copy and paste like the tables from lab and discussion into this, but you can also use the tables that we've uploaded. So these are the what do you call it? The tables from discussion, I think from a week or two ago, I think 2 weeks ago. And you can just, run your SQL command, select star from, I don't know, records. Oops, I can't spell records. And then you can see things like that, right? So one of the what was it? One of the problems in that discussion worksheet was like, oh, find. I think it was like find. I can't remember what it was, but let's say like we were dealing with this, and we wanted to find like pairs of people working together in the same division, right? If I wanted to do that again, I can't get that information, and I want that in one row. I can't get that information with just this table, right? Because I look, right, if I look at the computer division, I want like Alyssa and Ben to be matched and Alyssa to be and Sai to be matched, but that's not in one row. That's usually when you need to join it together, right? I would need 2 tables to solve this problem. And again, if we just try to join these tables together kind of naively without doing any filtering, we can see that a lot of these rows, first of all, it creates a massive table, right? This is what, a 10 by very large, probably 10 by 64 table. And that's a lot, right? But more importantly, a lot of this isn't useful, right? A lot of these rows aren't actually rows I want to keep. If, again, my goal is matching up by division, if I just look here, computer and accounting, they're not the same division. Computer and administration, all these administrations and computers, all these administration accountings, these are rows I don't want. So again, this is a great example of once you join, you want A dot division to be equal to B dot division. And then you can see, oops, if you can spell division. Then you can see you get, it's still a big table, but it's significantly smaller than before. Yeah, and then you can do even more like filtering. If I'm not going to go into right now, but there's a lot of repeats and duplicates here. But this is kind of to show you the online SQL interpreter, super, super great tool. Highly, highly recommend using it. And once you join, you always want to filter it out. And we'll see examples of that later on. Okay, so any questions before we move on to aggregation? I know some of you guys mentioned that you wanted to talk about joins. So any other questions about joins, anything I didn't explicitly mention, or any questions you guys still have?
Yeah, should we be using that table during the exam, or should we just be using that to practice but be able to kind of do them without it?
Yeah, I would say you don't want to use the tables during the exam. We're not going to give you the table, and that means you have to create the table from scratch probably, and that's, I would say, a bad time of a bad use of time. But if you want to try things out, like if you have an idea, I think you can use the SQL interpreter on the exam. But if you have an idea for like the exam problem, you're like, what would something like this look like on a practice table? I think that would be a good use of the SQL interpreter, also in practicing just to make sure you understand what's happening. But I would say creating the table during the exam is probably not the best use of time.
Cool. Yeah, thank you.
Yeah. Great. Any other questions? Could you post some guidance on how to use the interpreter under the file? Can you clarify what you mean by how to use the interpreter under the file? I'm not exactly sure I know what that means. But Wesley, isn't there a special case where you join with yourself, so you have to use a.names less than b.name, for example, you don't get repeats? Yes. So that's another thing I was mentioning. In this case, even though I kind of match by division, that filtering isn't like nearly enough. As we can see, Alyssa are matched. Alyssa and Ben are matched. Ben and Alyssa are matched. So this filtering was just to get rid of like the divisions that didn't even make sense. You wouldn't need to do more things where now we could say, okay, I'm not going to select star anymore. I'm going to select a dot name, comma, b dot name. And at the end, I can now say, and I want a dot name to be less than b dot name. And then you get actual pairs of people, right? So now you're basically saying, okay, what did this a dot name less than b dot name do? That basically said, this is a really cool thing to do if you don't want repeats and you don't want people to be matched with themselves. A lot of students just say like does not equal, but does not equal would only get rid of like Alyssa and Alyssa matched together. It wouldn't get rid of Alyssa and Ben and Ben and Alyssa matched together. So the less than basically says, okay, Alyssa, if you use less than with strings, like with words, A is basically smaller, Z is greater. And it basically says, okay, Alyssa is not less than Alyssa, it gets rid of that. Alyssa is less than Ben, it keeps that. And then Ben is not less than Alyssa, so it gets rid of that. So that's kind of how the how that filtering goes. But you would need to do additional filtering if you wanted to actually solve that problem like this. Are you able to reference a column without a name? Typically, columns all have names. So you usually want to have some kind of name on that on your columns. I'm not sure how you'd reference it without an actual name. Cool. Yeah, great. So again, if you have any other questions about joins or anything, you can either drop them in the chat or just unmute yourself and ask. But now let's talk about aggregation. So this is probably another place where a lot of people get tricked up is what is aggregation? How do we use it? So as you can see before, all the things we were previously doing were single row operations, right? It worked on one row at a time, right? It basically said, okay, in this row is like a dot division equal to b dot division. In this row, what's the difference between the names? Things like that. And that's useful, but that's not the most useful thing, right? If I wanted to find the average salary of people, I wanted to find the total amount of money I was paying my employees, the total number of hours people were working, things like that. I can't really do that on a line by line basis. I need some way to, aggregate things together. And that's where aggregation comes in. With aggregation, you have the ability to do things on multiple rows. By default, that means doing it on all the rows. So some useful operations, max, min, count, sum, and average, they work exactly as you kind of expect those functions to work. And if I just say, okay, select the max salary from records, right? It gives me the maximum salary of all the rows. And again, that's super useful. We couldn't do that before. But that's not that's only partially useful. One more thing we can do, and a lot of you guys mentioned this, is we want to group by. And this is where I think we lose a lot of students with SQL, and I'll try to slow down and go through it a little bit more. So what group by does is it basically gives us the ability to create groups of rows to do aggregate functions on instead of doing aggregate functions on everything. So here with this max salary or even average salary, I think that's probably a better example. It's doing it on all the rows, right? It's looking at this entire column and it's taking the average of that. Again, pretty useful. But let's say, I'm in the administration, I'm like the CEO or whatever, and I want to see like the average amount someone makes per department. That's a pretty common statistic you see. Well, I can't do that right now because I can only do it on all the rows. Group by would give me the ability to break it up by division. So now if I select the division, comma, the average salary, let's see how adding group by makes this different. From records, and I'm going to group by division. And now I get 3 rows, which might seem kind of weird, right? In my select, I'm still saying average salary, right? So why are these numbers different from this number? It's because of this group by. Now it's no longer doing the aggregate function on all the rows. It's doing it on the groups. What are the groups? Well, using this handy visualization tool, this is how you kind of split it up, right? I split it up by the division. So all the computer people are in one group, all the accounting people are in one group, and all the administration people are in another group. So once I have those groups, I call the average function again, but now it only works on those groups, right? It doesn't do it on all the rows. And then you get those three averages. So that's what grouping really does, right? It basically splits it up into smaller groups, and then you run the aggregate functions on that. The follow-up question is, what is having, right? Groups might make sense. What is this having, and where is that coming from? Having basically filters out certain groups. That's one way of doing it. Another way of thinking about it is you can't use aggregate functions in the where clause. So I can't put aggregate functions in where. You can only put it in having. So there's kind of two ways of approaching it, and it depends. Typically, you think of it as like, how do I get rid of groups? But there are some instances of, I think it came up in one of your homeworks, where you had to use having for a single row thing. But if I look at this table again, let's say I'm I like statistics. I don't. I really hate it. But let's say I'm saying I don't really want the average if there's only one person, right? That's not an average. That's just the person's salary. So I want to get rid of those groups. I don't want those numbers to show up. Well, how would I do that? How would I exclude this entire group? That's where I would use having. I need to use an aggregate function. I want to use count. So I know it has to go in the having area. So how do I add that? Well, once I group by division, I want to say having a count greater than 1. What's that going to do? That's going to split it up into the groups. And then it's going to say, out of these groups, or having, it's going to run count. Again, because it's split up into groups, count works on each of the groups. The count of here is 5, the count here is 2, the count here is 1. Greater than 1, it's only going to keep the groups where that count is greater than 1, which gets rid of the administration group, right? Because there's only 1 there. And then it calls the average again. And that's how we get our final answer, right? Which is pretty neat, right? That's a pretty cool thing.
So can we say that the having kind of filters our group by?
Yeah, that's
our grouped rows.
That's definitely one way of thinking of it. I'd say like that's probably what we usually teach. That's like the wording is like having filters out the groups. Because in this case, we saw that having count star greater than 1 filtered out the administration group. The more like technical way, I think, is you can use aggregate functions in the having, and you can't use it in the where. So having is where you'd want to put filters with aggregate functions. But typically, it's just filtering out the groups. Okay, lots of questions. Count tells you how many rows there are. Can you show how we could sort by average salary without showing the column? Yeah. So to do that, you would basically say, you would get rid of this, and then having that, and then you could probably order by the average salary. Oops.
I think the comma after division needs to get deleted.
Okay, oh no. This is one thing I don't like about the, okay, let's see if that works. Yeah, so that's one of the things, thank you, who asked that question? Thank you, Arya, for asking that question. One of the things that I talked about earlier, but I didn't really go into depth about, is even if you are not including certain columns, you still have access to them. They're not gone forever. So if I go back to I think the banana example, or fruit example, whatever it was, here, right? Even though we were only selecting the name and price, we weren't selecting color, we still have access to that, right? We can still say where the color equals orange. Select is almost the last thing that happens. It's just saying what to display, really. So even in this case where I wasn't selecting the average salary, you can still order by that. You can still order by count or things like that. That's totally okay. Yeah. So what's the best way of saying? In this class, you only need to worry about how to say count star. Count star is basically how to count all the rows. If you take future like data 100, probably 180, CS 186, you'll learn that you don't always have to have values in all of the rows for certain columns. And in that case, count star would just count the total number of rows, when count a column would only count the rows that have a value. In this class, all the rows have all the values for each column, so count star doesn't really make a difference. If I did count, I assume this is going to work, count salary, that's going to give me the same thing. So in 6Q&A, it doesn't matter, but it's a little bit easier to say count star. Is it possible to do a group by without having? Let's see. I think the answer is yes. So select, how do I want to do this? Select name, salary, from records, having max. Salary equal to max salary. So a group by clause is required before having. So I guess that answers the question. You do need to have a group by before you do having. I'm just trying to catch up on any questions I missed. What's the order that SQL operations are evaluated in? I don't know the exact order. I'm going to be honest. I feel like I learned it at one point. I'm sure you can look that up, but I think having probably comes last. From is probably one of the first things that happens. Then it's where, then group by, then having, then order by, and then select, I would assume. That's what I would typically say. Yeah, so we could also, like, if we wanted to group, if we wanted to get rid of the, if we wanted to do a different having, we could say like having average salary greater than, like, I don't know, $60,000. And then we can see it's only administration on average that's making that. So you can have whatever kind of having expressions you want there. Yeah, don't worry about tables where not all columns have the same number of rows. That is definitely out of scope for 6Q&A. You can look into it in future classes if you're interested in that. How do we aggregate before group by versus after? Does it just want to? Yeah, so you usually, if you're like doing anything with aggregate functions in groups, it does the grouping before you run the aggregate functions. So if you want to use an aggregate function without a group by, you have to use it in the select. So I can still like select average salary or max salary from records. Right, that doesn't give me an error. It's just if you want to have a having, you need to have a group by as well. And that's just how SQL is done. Can we use limit and order by after group? Yep. So as you saw here, you can use order after group. That's totally okay. And you could also like limit one. Totally valid. Order by and limit usually come at the end. So that's where that kind of comes from. So just to kind of go through what people wanted, we talked about group by earlier. We talked about having, we talked about joins, we talked about aggregation. We still have to talk about when, where, and having in the same command. Okay. So if we look at this, right? What can I do here? So let's say I want to do the exact same thing I was doing before. But now I want to say something like, I want to get rid of the people that make over $100,000 a year, right? Let's say I know that I don't pay my employees enough money. I know they're all making well under $100,000, and anyone who's making $100,000 or more is some like big time executive. I don't want to include them in the average. So how would I do that? Well, then you would want to say something like, okay, I still want to find the division, the average salary from records. But to get rid of that, you would need a where clause. I would want to say where the salary is less than 100,000. Then you would still group by division. And let's see what happens. And now we see that accounting and computers are the only ones. So what happened here? Basically what happened is I did this where clause and I got rid of Oliver. I got rid of Oliver Warbucks because he makes $150,000 a year. Got rid of him. Then you put it into groups, and we follow the same steps as before. You might be thinking, why did I have to use a where when before I used having? Because these did two different things, right? Before, this having included this aggregate function that worked on the administration group, right? And there was only one person there. That's still using groups, right? So I had to use having there. That's how I filtered out the administration group. In this one, I'm talking about individual people. On an individual level, I want the person making less than $100,000 a year. I have to go row by row for that. In this case, where the salary was less than 100,000. So that's one case where you can use where in group in the same statement. If you want to go even further, having, I don't know, count of star greater than 2. And then we see it's just computer. So in this case, I did the row by row filter of the individual salaries, got rid of Oliver, put it into groups. And then I got rid of this group because there's only 2 people. I want more than 2 people. So I had a having, and then I calculated the average. Yeah. So in this case, if I didn't have the group by division, I would get an error because I have having. Yeah. But if I got rid of these 2 lines, what would I get? It's some weird numbers. So this is another thing I will caution everyone about is if you try to do SQL can give you some really weird results if you don't know what's kind of happening. So in this case, right, I selected division and average salary from records where salary is less than 100,000. Why did I end up with accounting in 40,428? The reason I got that is pretty much it knew what to do with this row, right? And I just wanted the average salary. It didn't really know what to do with division. I would assume it's just accounting came first alphabetically, and that's why it chose that. But you do want to be careful with when you're selecting rows after using aggregate functions, especially if you're not using a group by, because you can get some weird answers like this. And again, I don't really know what's happening behind the scenes there. It's a pretty normal thing to get kind of odd outputs. So just be careful about that. If you're using aggregate functions without using groups, you might end up with weird stuff like that, right? In this case, an easy way to get around this is just get rid of this division comma and just get the average salary. Cool. So I've kind of been talking to you guys for like 40 minutes now. How's everyone feeling about SQL now? Is there any other, let me look, are there any other topics I wanted to cover? I feel like we did, we skip that. So any other topics you want me to go over before I start talking about like SQL problem solving, and then we start doing some problems together? Yeah, in this last example, I'm getting accounting simply because the computer, I honestly think the computer doesn't know what to give me. This is an example of what I'd say is not the best SQL query. This accounting is, I can't explain it. I don't know why it's popping up. It's pretty random. Again, because there's no group by, it doesn't really know what to do. I think it just chooses maybe alphabetically the first one. So to make this better, I would honestly just get rid of this division. It doesn't really play a role. Before I had it because it told me what the groups were. Now it's kind of useless. And then I can just get that. What's the best way to practice SQL while being able to use the SQL interpreter? Yeah, like Lena said, discussion questions are great. Old exam practice, really good. Most of the discussion questions are based on these tables that are in the online interpreter already. If you want to go through the homework and lab questions, you can just copy the create table as commands from the .sql files and just put them in and run it, and it will create those tables. And then you can like do the homework problems in the online SQL interpreter. I like the visualizations here better than like the terminal version that we include, the SQL Lite shell. So I recommend doing that. And again, these have all the visualizations. It's super great. Are we allowed to use code.csxna.org? I think the answer is yes. I think you can use code.csxna.org because we've been able to use them in the last 2 exams. If I'm wrong, I apologize. But actually, let me double check that before I do. Yes, you can use code.cs6una.org. Yeah, so you guys are good. Yeah, that would be mean of us if we said no. That being said, you have to use code.cs6una.org, not some other SQL, online SQL or Python interpreter. Cool. So now let's jump into so how to solve SQL problems, right? Like I said, knowing the tools is one thing. Knowing how to use the tools, objectively the harder part of SQL. So this is kind of how I go through it. If anyone else has any like really great tips, feel free to put it in the chat. But this is kind of what I think is a strong way of doing it. So figure out what tables we need. That's the from statement, right? Do I need one table? Do I need two tables? Do I need the same table twice? Where can, like the minimum number of tables where I can get all the information I need from? That's your from. Then, yeah, that includes how many copies of each table we need. So in that fruit example from earlier, we needed 2 of the same table. Figure out what columns we want from those tables. That's the select. So that's where aliasing comes into play. If you have like columns with the same name, you want to make sure you're aliasing. But again, that's kind of saying, in the end, what should my output table look like? You want to then filter out unwanted rows, where comes before grouping and all that stuff, like we saw in that salary example. So you want to filter out all the bad rows there. Group by, split it into groups. You have to decide if that's necessary or not. Filter out entire groups if needed. That's where you use having. You can sort your results. Again, after like 0.4 or so, this is like an optional thing. Like, do I need to group? Do I need to have having? Do I need to order a limit? This first stuff is not optional. So you need to have a select. You need to have a from. Where is optional? Everything after 3 is optional. So then you can decide if you need to sort by. If you decide to sort by, what order? Finally, you want to make sure if you're limiting. So that's just saying how many rows do I want in my output table. Okay, if the instructors on Piazza said you can use that, I guess I am wrong. What's an example of we might need 3 copies of a table? I guess if you wanted to find like triplets of fruits that all had the same color, I don't think that table would fit with that because I think the maximum number was 2. But in an example where, let's say I had a table of everyone, everyone in this like Zoom call, and I wanted to find like triples or trios that like the same color or something like that, you would need to use the same table 3 times to get all that information in one row. Does limit n limit the number of rows to the first n results or the last n? The first n results. Mm-hmm. Yeah, great question though. So it's the first n results of your output table. So like if you didn't have a limit, what would the first n rows be? It would just take those out. So you would have to get rid of repeat choice. Yeah, if you had 3 people, you would have to get you would need to do probably 3 checks for getting rid of repeats, where it's like A is less than, or A is less than B, and like B is less than C, and A is less than C, I would think. Order by syntax is descending and ascending. Yeah, so you would order by some expression and then ASC or DESC. Yeah, great questions though. Any other questions? Nice. So no more questions. Let's put you guys into some breakout rooms. So here we have a problem from the summer 2017 final. You can find this in the slides. And I'm just going to put you guys into breakout rooms for this one question. We have these 3 tables. We have all these things. Oh God, 9 people left when I said breakout rooms. And we want to like write this query for solving this problem. So I'll open up the breakout rooms. Please stay. I promise it's going to be fun. I'll go through the problems once you guys are done. But I'll bring you guys back in like probably 5-6 minutes or so once you've had some time to work on this problem. And then Alina and I will be going out throughout the rooms and helping you guys out. Cool. So let me open up the rooms. Automatically create. Yeah, a lot of people. Oh my God, 20 people have left. That makes me sad, but it's okay. Okay, let's automatically create these rooms. And yeah. Okay, so I will open up all the rooms. So again, I'll bring you guys back in like 5 minutes or so, but Alina and I will be going throughout the rooms to help you all out. Resume recording. Cool. So for the people watching the recording, I forgot to turn it on, but pretty much what we discussed is we know we need to select the username and the rating from our end table, and we know we're going to need all three, users, products, and sales, to get the username, to get the rating, and for sales to match the user to the product so we know who's buying what. And we know we need to alias because PID and UID are repeated. Thank you so much for that reminder. So then we think, okay, well, what would I need a where for? It doesn't look like we need to filter out any specific rows, right? We're not saying the rating has to be greater than blank, or the time they bought it has to be this, or the username has to start with this. The thing we need to use where for is we joined the tables together. And like I said, we get a lot of kind of nonsense data from that. And this is a perfect example of that, right? If I do a join between all of these, I'm going to get a bunch of rows where the UID, the PID do not match with sales, right? It will say like, oh, Richard bought, like Richard's username, and then like some random time PID and UID that doesn't match my UID, and some product I didn't buy. And as you can see, that doesn't really make sense, right? Those rows don't matter at all. They came from matching everything together, but I don't care about those rows. I only care about the rows where it's my username and the product I bought and the ratings for that. So what do I have to do? In my where, I'm going to say I want my UID to match the u.uid needs to match the s.uid. That makes sure that all the sales are mine. But on top of that, I also need to say that the PID from sales has to match the product PID. If you didn't have either one of those, you would either have the correct match between sales and products, giving you, the correct products that people bought, but the wrong users, or the correct users and the times those users bought things, but not the correct products. Having both of them guarantees that, okay, Richard bought like a baby Yoda figurine at this time. It has the right username, it has the right product at the right time. So all three of them are in sync. And again, that's really what you have to do after you join things together. Cool. Great. Any questions?
Oh yeah, sorry. Could you say why we alias in this question, or when we do it, maybe just in general?
Yeah. So that's one of the things I mentioned some of the breakout rooms, and I think this is a really useful hint. If you need to alias, look at the tables you're using and see if there are any repeat names. So in this case, I know I need to use all three, right? I can see that PID is in sales and products, and UID is in sales and users. That means in this overall table, there's two UID columns and two PID columns. And if I just said I wanted the UID column, you wouldn't know which one to give. So it would give you an ambiguous column error. So in that case, if there are any repeats in the names, then you want to alias. If there's not, there's really no need to alias. You can if you want, but it's not required.
Thank you.
Yeah. And you do need to use I would say I like if you're going to alias, just use aliasing throughout so it's clear where the things are coming from. So I would say like u dot a uname and p dot rating, even if those are unique columns, I think it's best to do that. Cool. So we have the select, we have the from, we have the where. Doesn't seem like we need to group by anything, but let's think about the rest. So now we have essentially a log of who bought what at what time. How do we go on from there? Well, if I want the highest rated product, then I basically want to sort by or order by the product rating column. So then that would have to be in my order by. I would order by p dot rating. And would I want that ascending or descending? to get the highest rated one. What do you guys think? I want that descending, right? I want the highest values at the top and then the lowest ones. So that would order by p dot rating descending, and then limit 1 just takes the top row, and I get the username and product rating from that. And that's all we really have to do for this. One idea I heard is using max somehow, using the max rating in this. You can do it that way, but it is a lot more complicated, and I don't think it would fit into this skeleton code. So just be wary of, there are usually some alternate solutions, but sometimes it doesn't match the skeleton code because that solution would require groups and halving, and we don't have that in the skeleton code. So if you can think of a solution and it doesn't fit the skeleton code, try to think of another way to do it. I would say that's a relatively rare situation for SQL questions, but it is something you have to worry about. If you did use that max rating, I don't think you would need to use order by, because it would give you the max rating and you just randomly pick one of them. Nice. Any other questions on this problem?
I have a question about the aliasing.
Yeah.
Can you just use like the table name dot like UID, like users.uid and sales.uid rather than aliasing?
Yes, you can. That's totally okay. The reason why we use aliasing over that is U takes 1 character to write and users dot takes 5. In like P versus products and S versus sales. So you could just use the full table names. That's totally acceptable. It just saves a little bit of time in aliasing, but that's all it does. It's a time saver.
All right, thanks.
Yeah, that's a really good question though. Great.
And I'm not sure if I understood that correctly. It kind of made it sound like aliasing was like optional in this question, but I thought it like we had to alias.
Yeah, you do have to do something in this. You like the way of doing it without aliasing is basically you have to write like, I want the users.uid column or the sales.uid column. So in that case, you don't have to alias because it's not ambiguous. I'm saying I want the column from this table, versus in aliasing, it's like u.uid and or s.uid. So either one of those is fine. Typically, you're going to see aliasing because it saves time and you're not writing the full table name every time you want to access a column. Yeah, hopefully that makes sense though. Great. So I'm going to do the next, just out of interest in time, I'm going to do the next 2 problems with y'all, just so we can get through a couple more problems. Because I think if I put you in the breakout rooms and take you back, it might take a little too long. So let's say we have this, now we're going to deal with some movies, right? We have this table of movies, and we're going to have to answer some questions about the movies. So it has the budget, the box office, and if it's science fiction or not. So I'll give you guys a couple of minutes to look at these problems. The answers are in the slides, so if you don't want to see the answers, don't go further in the slides. But the 2 questions are, we want to write a query that outputs the budget that appear more than once in the table of movies. So think about how to do that, the budget that appears more than once. And the second one, write a query that will output a list of science fiction movies ordered by the return of investment ratio, which is box office divided minus budget divided by budget, from greatest to least. So I'll give you guys like 2-3 minutes to think about these problems, brainstorm them. Again, I won't put you in the breakout rooms out of interest of time, but if you have any questions working through those, you can put it in the chat and ask Alina and I. Yeah, so just answer some questions in the chat. Do we use single or double equals for equality? I think both work in SQL. I think single is correct though. I think if you use the online interpreter, at least double will work as well. And then the second question was, can you do and statements in having? I think you can do and statements in having. I don't think I've ever seen a version where it had an and statement in having, but it is, I don't think it's prohibited. I'll give you guys, actually, I'll start going over the, yeah, so if you're using any aggregate function, you need to put it in the having clause. I think it will error if you put it in the where. But I'm going to start going over this. I might go a little bit late, so I'm sorry if you have another place to go, but you can feel free to leave when you have to. So for this one, we want to write a query that outputs the budget that appears more than once in this table of movies. That's similar to what we've been doing before, right? If I'm counting things like this up, I'm probably going to use count, which means I need to use groups. What should I be grouping by in this problem then? If I know I need to use groups and count, what column or expression should I be grouping by? If you guys want to put your guesses in the chat, I should be grouping by budget. Yeah, I want to group by budget, put those in its group, and count those groups. See which one has a count greater than 1. So if I kind of go through our steps, I'm just going to use this movies table. So from movies, I'm selecting budget. Okay, so select budget from movies. What's the next thing I need to think about? I don't need to use any where. I'm not filtering anything. So then it goes to group by. I want to group by budget, like you guys said. And then having, like we said, we want to having count greater than 1. So having count star greater than 1. And then we don't need to order by, and we don't need to limit. So our final answer here is just we want to select budget from movies, group by budget, having count greater than 1. So again, that kind of 7-step process of going through the problem, I think is super, super useful. I think it helps a lot with figuring out these SQL problems. So you typically want to do group before any aggregate function, because at least in this case, you want to do the aggregate function on the individual groups of budgets. So we know how many budgets had that same, or how many movies had that same budget. Which is kind of the reasoning behind why we group first and then we count. We need to figure out like what the groups of budgets are, and then we want to figure out how many there are in each of those groups. Cool. Any other questions on this first problem? Cool. Again, if you do, feel free to leave them in the chat. For the second problem, write a query that will output a list of science fiction movies ordered by the return of investment ratio from greatest to least. Okay, from step 1, from. It seems like you can do this all with one or just to answer a question. I think this table is defined as as just the columns called movie. The table doesn't necessarily reflect that, but you can just use movie as the title there, as the column name. So I know I can do this with just this table, right? I don't need to join, don't need to do any of that. What I do need to do is ordering is probably going to be the most difficult thing here. So I want to select, and it says I just want the movie. So I want to select the movie from this movies table. And then where? Do I need to filter anything out? Well, it says I just want science fiction movies. That's something that's filtered out row by row versus groups. So I'm going to use where for that. So where, I think it's SF equals true. Yep, we see SF, and we want that value to be true. So select movie from movies where SF equals true. And then I don't need to group by. I'm just doing things on rows. I do need to order by. And what do I want to order by? You want to order by this return of investment ratio. And that's the thing about order by. It doesn't just have to be a column. It can be any expression, but of columns. So I can say like BO minus budget divided by budget, and I want to order by that. So that's a totally valid thing to do. And I'll show you kind of what that looks like in a bit. And then from greatest to least, so that can either be, there's two ways of kind of doing that, and it's kind of weird. You can either order by, BO minus budget over budget, descending, so you have greatest to least, or you can do it with a minus sign in front. So it's like negated. The default is ascending. And if you kind of think about it, if there's like a negative inside in front of it, then like the smallest number comes first, and that's like the biggest non-negative number. And I think that's what the solution here says, where we want to select the movie from movies where science fiction is equal to true, and then we want order by negative budget minus or BO minus budget divided by budget. This can also just be order by this expression descending, DESC. Yeah, and again, the reasoning behind this is like if it's like 100, 90, and 80, negative 100, negative 90, negative 80, that would be the correct order in ascending. So you can just negate it. Yeah. But either one of those is fine. I think typically nowadays you see descending. Yeah. The syntax here isn't as important, I'd say. In this case, SF is the column and true in quotations is how the column was made. But like as long as the idea is there, I think you're totally okay. This is kind of weirdly worded. Sorry about that, with all the columns and things. But any questions on either of these two problems? Are there Booleans in SQL? I think it depends on what kind of SQL interpreter you're using. I think sometimes it might just be zeros or ones. I think that's what SQLite does. You're either going to get a 0 or 1 in the end, which is like the Boolean false and true. Can we do Q1 without group instead saying, yeah, so you couldn't say that simply because if you wanted to say where count budget is greater than 1, that would need to be grouped first. And then that would have to go in the have it clause because where can't have aggregate functions. Cool. Any last questions? Sorry, I'm going a little bit over. Cool. Well, if there are no more questions, there are some practice problems we didn't get through. In these slides, I would highly recommend finishing them up, reviewing discussion problems, CSM worksheets, lab and homework about SQL. It is one of the later topics, so we didn't go into it as much, but there are a lot of problems that you can go over. Use the online interpreter, make sure you're kind of following those 7 steps of solving the problems, but hopefully you guys learned a lot about SQL today. If you have any questions over the next week about the slides or about anything SQL related, feel free to email me. My email's on the website. I'd be happy to help you guys out with your studying. Good luck studying, have a productive dead week. And yeah, good luck on the 6 Q&A final. Sorry for keeping you guys a little bit late.